Broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone, and thank you for taking time to join us for this webinar today. The subject of today's webinar is an integrated approach to pipeline integrity and corrosion applications. Also, we will share the extent to which the integrated data environment of Technical Toolbox's Pipeline Hub and the engineering tools it supports facilitates greater productivity and higher standards of quality for pipeline engineers in this integrated approach. As we shall see, digital integration makes it possible to provide pipeline engineers with a more complete solution. As always, our goal is to provide thought leadership, support engineers, and cultivate professional development. We design our live webinars for your participation. We invite you to join in. Take part in a couple of brief interactive polls, post your questions in the chat box through the webinar, and stay for the Q&A session to hear some responses from our expert. Our speaker today, Joe Pikas, has more than 50 years of corrosion and integrity management experience in pipeline engineering. During that time, he's worked in pipeline construction, operations, corrosion control design, and implementation. He's an expert in pipeline integrity and risk coatings, cathodic protection design, and AC mitigation. In 2009, Mr. Pikas was awarded the NACE Distinguished Service Award. He's received many other awards from the most esteemed organizations in the industry. He's contributed more than 50 papers to industry trade magazines, other publications, and conferences. As a consultant and instructor for technical toolboxes, he's been a guiding influence on software development. As a PDG instructor, he shares his knowledge of pipeline engineering management and years of work in the field. Before turning it over to Mr. Pikas, I am going to launch a brief poll that we would appreciate your responses in. Alrighty, I will close the poll and I appreciate your responses. And at this point, I will turn it over to Mr. Pikas and he will go on with his presentation. Joe, I think you may be muted.
Good afternoon, Paul.
We can hear you well now. Thank you.
And good afternoon, everybody. And thank you for attending. I'd like to start off with integrity, one of my favorite subjects. And one of the things that I've been involved in, of course, over the years, we actually got started in 1990 by a very young vice president. And that's how I got involved in it. Factors are often associated with higher risk and includes the pipeline age, the materials such as coatings and things of this nature, the pipe itself, the higher strength materials, and the operator's practices in managing the integrity of the pipeline system. And let's talk about materials, because materials tend to fail, and such as coatings, and which leads to my next bullet point. An older pipeline does not necessarily have a higher likelihood of leaking or rupturing. Why? Well, believe it or not, some of the older coatings weren't that bad. And going back in the early 1990s, I know of a company that put a system in, a pipeline system in, using hot applied shrink sleeves. And what happened within 6 years, they were failing. They ran a smart big run, and lo and behold, you could see corrosion beginning, starting at the bottom of the pipe, underneath every 40 feet. And this is not a good thing. And yet the old 75-year-old pipeline was performing well. Why? Well, let's talk about some of these things. And then the idea of PHMSA has recognized some of these things that have gone on over the years. Materials, sometimes not having adequate construction, inspectors on the pipelines and things of this nature. So the mega rule come along, and it covers just more than construction. It covers a whole multitude of applications, for the pipeline operator. And it's all about the integrity of the pipeline, putting more emphasis, having TVC involved, traceable, verifiable, and complete. And it's about failures that would affect areas of high consequence. And what I mean by that, you don't have to be in a high consequence area, such as the disaster that occurred in New Mexico, where a family of 12 were killed by explosion. So keep that in mind. So it doesn't always have to be an HCA for things to happen. Next slide, please. Factors often associated with higher risk. We're committed. The key to this is we're committed to zero incidents. We can never get there, but we need to have that goal. That's the goal of what's needed for pipeline operators. When I was in the industry, I was in a class 3 and 4 area, and we were committed even back in the 70s to zero incidents because of these type of issues. So integrity just didn't fall out of the tree yesterday because the regulators come out with a mega rule. And it has to be a culture and a climate, to continuously improve. It isn't one person waving the flag. It has to be everyone involved, even beyond the company, and we'll talk about that. And it's a relentless improvement by learning from, and what we say from the past could be yesterday. And it's the unanticipated issues that we have to be thinking about for the future. Not just anticipating the future. We want the future to be bright. And commitment, applying these principles. And when we say it on a system-wide basis, what we're talking about is not up and down vertically. We're talking about totally across the system, that no one's left out. Everybody's playing a role, no matter how minor. And this is one of the things I've seen over in the industry is it goes great up and down the ladder, but it doesn't always go out. And that means out to the field and beyond. And that includes my next slide, communication with the stakeholders. Oh, I'll go back one. The stakeholders, which includes areas like the people that are adjacent to the pipelines in the right of way. Give you an example of that, the communication, the local community. The local community has to be involved in a sense that, I'll give you another example. We're doing a survey about 20 years ago, putting out data loggers. And one of the things we found was the people, and this is up in the New Jersey area, the people are asking us all kinds of questions along the right of way. Why? Because they didn't know who we were. And these people were the eyes and ears of the pipeline. They kept their eyes and ears, and they told us point blank. And that's how it works. So it works with the local, local people and the community there. The next slide, please. And then ongoing approach, collection of data, performance data. This is what we're dealing with. Live data, the surveys, the inline inspection data, the ECDA surveys and things of this nature. And then in being involved with the trade associations, where you're involved to better manage the integrity of the pipeline. Getting the latest information from API, ASME, NACE, and others. And the other thing we need to think about is we need to think about the integrity that the operator truly understands the characteristics. And what I mean is when we talk about the environment it operates in, it's not just what's on the right-of-way, it's what's below the right-of-way. It's the environment below what's going on in the ground. And that includes the soils, that includes subsidence and things of this nature. So because if we have corrosive soils, aggressive soils, we need to be thinking about what's going on below. Next slide, Paul. Okay. So, what happened here? Corrosion tools. One of the things that technical toolboxes have been involved in right from the late 90s was tools such as this. They've been involved with PRCI and others, but more importantly, tools such as AC mitigation. what does AC mitigation do? It not only mitigates, but also determines where the areas of concern are along the pipeline, particularly with fault currents and things of this nature. That's how important it is. This is one of the things the regulators are looking at. What impact does that tower have on your pipeline? We also have tools, what we call the Pipeline Toolbox, PLTB, both the gas and liquid version that involve CP calculations. These are similar to NACES calculations for assessing and determining and designing ground beds, and also assessing corrosion. Which brings us to R-string, which has been around about the same time technical toolboxes have been around. And R-string is one of the most used calculations around the world, not just the US. And why? We now have a version called R-string Plus that allow you to do multiple effective areas. It's the only tool out there that can assess this. And why? Because corrosion lengths have increased over the years. This is what we're dealing with. We're also dealing with GIS mapping. I mean, this is all great to have it written down somewhere, but where is it? Where's this happening? How could we do assessments? How much is really going on in one area versus another area until you map it? And this is how important mapping is in today's world. You need to have this type of mapping to see what's trending, where the areas of concern are occurring, and why they're occurring. Next set of slides, Paul. Example. Here's the AC mitigation tool. This is one of the areas that I was involved in putting data loggers out years ago, and this just happened to be what we're looking at is industrial, commercial, and residential all together. Keep in mind, Jersey is the most densely populated state in the country, and you got it all together in one place. And right next to it is the New Jersey Turnpike over on the right side. And so you can understand you have to have zero incidents. There is no room for error. Errors don't occur in this area. Otherwise, a lot of people can get hurt. And this is why we need to be alert to have tools such as this. So because everything's jammed in one right of way. It's not just one pipeline, and it's not just one set of tower lines. It's a whole set of tower lines. And not only that, I'll give you an example. They could have, the area we worked had 5 substations within 15 miles. And they interchanged them all the time. So try to run your calculations on that. But these are the kind of things that we look at and we could assess. These are the kind, we have tools that will help us assess these situations. And I'm just giving you an idea of a short section that we ran up there. So anyway, just to let you know that the information comes out very, very quickly. And also the faults. You could determine the fault currents on tool with these type of tools. Next slide, Paul. Okay, not only do we have integrity tools for pipelines, but we also have some tools for inside the fence, API tools. We call it the API Inspectors Toolbox. And it does 510, for your vessels, 570 for your piping systems, and 653 for your tankage. That's above ground ASTs, above ground storage tanks. And again, they have the same, API has the same requirements that ASME and others and the regulators. They still have to perform their assessments either on a 5-year interval or less, depending on their reassessments. and what they find. And the same thing, we have a tool called the 1104, the weld imperfection tool, for determining issues with wells that are not up to speed. So we do have it'll determine the crack opening and the whole 9 yards regarding the 1104 weld tool. In addition to that, we're going to jump back to pipeline integrity tools. Is we have the HydroTest Power tool. It's a great tool for designing and for operations. And this tool has really taken off. You could do multiple segments, sections, whatever you want to call them, and it's almost unlimited, based on your needs. And we'll talk about those needs could be based on many different things, such as elevation, such as class location, wall thickness changes in pipelines. We also have an investigative dig power tool for ILI and things things that you could do comparisons of one run versus the other and things of this nature. We also have the pipeline toolbox gas and liquid for accidental gas releases, and both minor ones, just a small opening versus a guillotine failure where the pipe separates and you have gas coming out both sides. We have calculations for that. We also do additional pipeline testing if you want to do just a small job, for purging and miscellaneous calculations. We have calculations for relief valves, and then also we have liquid releases too, which considers both the immediate release and then the release based on elevation. So not only we're looking at both gas, we're also looking at our liquid version too. Next slide, please. Okay, and this is our HydroTest tool. Again, I took this same area up in the Northeast, just for to run some calculations. And again, just to let you know that these tools can be run very quickly, knowing your class location, your elevation changes, and things of this nature. In this case, I ran something, I believe it was okay for running it for about 13 miles. It gives you the elevation. It gives you the GIS version of the mapping where it is, and also a full-blown reporting section. Whatever calculation you're going to be running at, if you're going to do the minimum 125 or the 110%, and also the max, you could run all these calculations very quickly, to determine your integrity of that pipeline system. And what's nice about these tools is the reporting aspect of it, where the regulators can see every aspect of how this was designed. Next slide, please. So one thing we get into is, again, encroachment, crossings. This is our approach. We talked about what the regulators are looking at, okay? What is Technical Toolbox's approach to this, okay? So now we're looking at, the pipeline toolbox, again, the gas and liquid version. We have what we call our crossing workflow. We've got the wheel load, track load, 1102, The GPTC, the Gas Piping Technology Committee, uncased wheel loads. That's a good one that a lot of folks don't even think about because that one fits in where you have unusual wall thicknesses, but diameters. Like you have a 48-inch line. You have unusual conditions. The GPTC fits those areas that the other tools, don't usually calculate. We also have, and our wheel load and track load are probably one of the most used tools in the country and Canada and others and around the world. And then then we also have our HDD power tool, horizontal directionally drilled power tool, both for steel and plastic. And this is another tool that has really taken off, around the country and actually around the world too. And we got the light version that comes with the pipeline toolbox, and then we got the power tool, which we recommend because you could do more than 5 sections, and we could do a whole host of calculations, not only just pull throughs, but determining areas of concern too, when you're calculation, because we have a backup of many tools on deflection and things of this nature. Also, we have reporting tools, asset management. That's the asset management right now. We have it primarily for the API tools, but it's going to be moved over also to the pipeline tools. And then we got a report builder that what used to take hours to do, these tools will do it in literally, I want to say minutes. You could reduce those hours down to minutes because it'll give you a title page, it'll give you a summary, it'll give you a table of contents. You don't have to worry about all that stuff, and your report builder could literally build out or spit out a report quicker than you could think about it, and it really does a fantastic job. We're gonna go next to I believe encroachments, which Paul will take over next. So yes, Paul, I'll leave that up to you. Okay.
Thank you, Joe. Appreciate it. Yeah, technical toolboxes is preparing to launch the Encroachment Manager application. It's basically the latest in a long lineup of tools available on our hub platform that you and your company can help you and your company reduce OpEx, CapEx, reduce risk, and accelerate project schedules. The Encroachment Manager allows collaboration across all aspects related to encroachments and all functions within your organization, including engineering, regulatory, and management. It is the foundation for litigation and audit defense, and will allow tracking of all pertinent information for every encroachment. Have you ever asked yourself as an engineer, how confident are you that no errors exist within your solutions? And how does your organization ensure engineers are using the correct data from a trustworthy source? The Encroachment Manager provides a single repository for all encroachment-related projects that ensures trusted data, trusted calculations, a holistic analysis, and TVC documentation are taken into consideration. We look forward to working with you to see how the solution can benefit your organization. On this slide, we try to show how the Pipeline Hub from Technical Toolboxes provides a cost and risk reduction and digital transformation by bringing the encroachments into the integrated data environment of the Pipeline Hub. The graphic shows different data sources available on the Pipeline Hub platform. The tool represented by the boxes are interconnected via the hub. The color coding reveals the relationship and histories of the apps. For example, dark blue is IP developed within Technical Toolboxes. The other colors indicate data integrated from external sources, and gray shows public data and plugins. At the technical toolbox integrated data environment is an expanded and robust set of pipeline engineering tools for integrity management. Technical Toolboxes provides many calculation apps and power tools that integrate with the pipeline hub within the pipeline toolbox. The PLTB alone has 350 tools for gas and liquid pipelines. We support professional development with live training events, and we've transitioned successfully to online webinars due to the pandemic. Webinars range from an hour to multi-day events. We expect to return to in-person and on-site classes when conditions are right. However, we still provide the same high standard of training, support, and credit for professional development hours. Upcoming training schedules include understanding underground pipeline coatings, external corrosion and direct assessment, and many more related to corrosion, encroachments, and integrity management. You can check out the upcoming schedule on our Technical Toolbox's website for a complete list. At this point, I'll launch the second of our polls, and we would appreciate participation if you would. Looks like the responses are coming in. Looks like we got most everyone. Thank you, everyone, for participating. We appreciate it. And we will move on to the next slide. So at this point, we will have a Q&A session after the session here. But at this point, we would like to ask, what are the next meaningful steps for you? To see how the integrated data environment of the pipeline hub can impact your integrity management practices directly. You can reach out to us directly for a software demo. You can register for professional development training and or webinars and or contact us directly for that. And then again, we'd love to hear from you for our Q&A session following here shortly. At that point, within your control panel, you should be able to find a point where you can submit questions for the Q&A, and we encourage you to submit those. And at this point, I'd like to turn over the floor to our Engineering Performance Advisor, Joseph Ladner, who will lead our Q&A session. Thanks, Joseph.
Yeah, appreciate it, Paul. For everyone that joined the webinar today, hopefully you found it to be beneficial, not only from learning the various integrity-related solutions that Technical Toolboxes offers, but just getting a little insight on pipeline integrity as a whole. So I do see some questions are already coming in. I'm going to get to those here in a second. I don't know if Paul mentioned this, but I do want to reiterate it if he did. We're going to be having I'd like to call it a phase 2 to this webinar. It's going to be a 3-part series. The second one will be specifically expanding on a subcomponent of today's topic, which is encroachment management. We're going to be talking about all aspects of encroachment management. What does that mean in our industry, not only in North America, but worldwide? And then also take a real deep dive into the latest and greatest solution that Technical Toolboxes is going to be rolling out to the industry come January 2022. So be on the lookout for that. We'll be blasting that around come January, and that webinar will be, we're shooting for late January for that to take place, and we'll have another SME, Alfredo Sainz, there with us specifically in regards to encroachment management and crossings. So be on the lookout for that if it's of interest to you. Now with that, Mr. Pikas, I don't know if you can hear me, sir, but we have questions rolling in. I already have roughly about 6 lined up and ready to go, mostly pertaining to software. But the first 2 kind of go hand in hand, Joe, and it's going to be related to AC mitigation. Looks like we potentially have some AC mit questions, maybe users on here, but nonetheless, Joe, The first question I have for you is going to be, can the AC mitigation power tool determine areas of corrosion, areas of AC corrosion, sorry, due to high current densities such as 50 ohms per meter squared, or 50 amps per meter squared, sorry. If you need me to repeat that question, I can, Joe.
No, I heard it. Thank you, Joseph. Yes, one of the things about the AC mitigation program is you can select your own criteria. In other words, some companies go as low as 30 amp per meter squared. And of course, that's based on having a DC 1 amp per meter squared on the pipeline, meaning they're really overprotecting their pipeline. And so that drives up the requirements to have a lower AC current density criteria or criterion. So these are the kind of things that you as the operator could make a decision on based on what's going on the pipeline. And of course, the program will assess those areas of concern, whether you use a 50 or a 30 or 100 amp per meter squared. And there was a second question, is that correct?
Yeah, pertaining to faults, Joe. So does the AC
yes,
fault program calculate voltage and currents for all tower locations?
Yes. One of the things that one of the operators came to us about a couple of years ago and said, the regulators have been really asking a lot of questions, not about AC corrosion, but what's happening to your pipelines when there's faults, and how close are those towers to the pipeline, and what effect are it's happening on them? And what a great question. And he says, can your software calculate all the towers? Well, of course it could. All you have to do is create a node for each one, and that's pretty easy. That's point and click, and you can create a node for each of those towers based on proximity, and so the regulators have been taking note for quite a while of the different impacts that the faults have, both on the coating, creating burn-throughs, and the pipe itself. When you are in a proximity situation where the distances aren't very far, and what we're seeing, and this is nothing new. What we're seeing is of course, particularly in the area of Texas, when you have 156 different pipelines in one right of way, and it's mixed in with power lines, you've got a problem waiting to happen. So the nice thing about this is again, using your mapping system. The program will calculate the distances between the towers and the pipe, each one of them as you lay it out, and give you and calculate them all at one time, and that makes satisfies not only the regulators but satisfies yourself of what's going on and what could happen. If there is a significant fault, and what we're talking about is mainly those conductive faults or resistive faults. Okay.
Yeah. Appreciate that, Joe. I have a number of questions here, but I'm going to stay on the topic. We have a question come through that kind of sticks to AC mitigation. So the question pertains to regarding AC interferences, Joe, in pipelines. Have you experienced these interferences in very low resistivity soils with resistivities around 5 ohms per centimeter? And how would the software handle that if it can?
Absolutely. That's a great question. Yes, when you have resistivities such as in brackish water, the voltages now to create a corrosive AC corrosive environment are going to be less than the volt. And if you have something, I don't know, I never ran into 5 ohm centimeter water, but or environment, but I've ran into 30 ohm, and you could have a half a volt and have AC volt, and have a corrosive condition. In fact, I know of a case where they had a leak in one of the local rivers here. I don't want to give it away which river it was. So, but anyway, in the Houston area. So I just want to let you know that these can occur. So buyer beware when you're crossing these brackish water systems, rivers, particularly in the area, the Houston Gulf area. You're subject to some very low AC voltage issues.
Gotcha. Appreciate that, Joe. Going to we're gonna get off the topic of AC for a second. I'm gonna try to make sure, a lot of questions coming in, make sure I cover it all. For HydraTest, we're gonna go to HydraTest. Pertaining to the program, Joe, can it create more than 10 segments? Looks like this particular operator runs long link transmission lines. Can it create and handle more than 10 segments due to elevation changes, class locations, change of wall thickness, etc.? Can the program handle that? HydroTest Power Limited.
Absolutely. I think we tested it to 25 or 50 segments. I can't remember, but yes, it'll handle way over 10. So folks that have a major HydroTest program going on, and they want to run from state to state, they could easily run as many segments as they wish, and determine where the breakpoints are and things of this nature, and make it contiguous all the way through, which is nice. So it'll all be on one program, where it won't be broken up, and you'll be able to track everything a lot quicker. So that was a great question.
Yeah, I got a question to answer that I can get an answer to pretty quick. Any statistics on encroachment case histories in USA or Canada to share? That's a really good question and pretty high level. We're going to go into that in just a tad in our next series of webinar with our encroachment SME, Alfredo Sainz. We'll definitely follow back up with that question and the submittal to that question on maybe clarifying exactly what you're looking for. But we do have information to share, and it would be just the product of pulling that information up and sharing it. So again, the question for any statistics on encroachment case histories in USA to Canada, we'll certainly follow up with you kind of individually on that one. Now with that, Joe, R-string, let's go back to corrosion for a second. Someone picked up on that potentially R-string plus can assess more than one effective area. Is that the case, Joe?
Yes. One of the things that we recognized years ago was when I was still working in the field too, was we're beginning to see area. When they put R-string together, it's probably the maximum length of corrosion we're seeing, and that was back in the late 90s. It was probably 18, maybe 20 inches long, and since then it began to get the corrosion lengths begin to get much longer. In fact, seen them from joint to joint. That's pretty bad. And so the question comes up: Can the program handle something like that for, let's say, a full joint? And yes, it can. And so that means it has to determine multiple effective areas. How many are there? There could be many. And this is the nice thing about the program, because if you have contiguous corrosion from one end to the other, it all has to be considered, and the program will handle that. The program could always handle it, but the point was it didn't. It couldn't segregate it out. And now we have the capability. It was just a simple a process. It wasn't a calculation, just a process to be able to do that. The calculations never changed. It was just a better way of doing it, and that makes a big difference on all of this. Is able to calculate all this out, take that data, and actually just put the areas of concern as areas that this is where your mitigation needs to go if you want. Otherwise, you could always cut the joint out. You could always do a continuous Band-Aid across the pipe of composite sleeves, or you could put them specifically only in the areas of concern, which are a money saver. So whether you're using a type B pressurized sleeve, or if you're using a composite sleeve, this would fit very well of just repairing those areas exactly where the metal loss affects the pressure of the pipe. And so we built that in the R-String Plus program, and I think you'll like that part of it if you're doing a lot of digs each year.
Okay. Separate question, Joe. We're going to go, got a question of a tool we did not talk about today. And the question kind of pertains to what tools does Technical Toolboxes have or recommend for integrity assessment of subsea pipelines?
That is a great question. And, we have our on-bottom stability program where, where there's concerns of spans and things of this nature. But as far as offshore is a whole new ball game because they're using remote control vehicles and a whole host of other type of tools. We don't get into that specifically, except for the on-bottom stability program, which has been updated, both for calculating new designs as well as looking at existing systems. And if you're looking for structural integrity, where there's areas of washouts and things of concern and currents that are of concern. That would be a tool that you may want to look at, but it's specifically designed for for that purpose.
Okay. Back to corrosion, Joe. ILI, the investigative dig power tool that you mentioned, can it assess 2 surveys to determine if additional metal loss has occurred?
Yeah, this is one of the things about you could take this tool will allow you to take your past survey and your current survey and make a comparison of them, and where you don't have to go in manually and you could look and see what has changed, since my last survey, and this allows the user, to make those assessments of, are we controlling corrosion? Where do we have new areas of concern? Why is the corrosion increasing? So on and so forth. So these are tools that are making our life a lot easier, compared to manually doing a lot of this work. So we've come a long way. Of course, you got to use the same company because the way tools sometimes are measured, you know, the anomalies are measured, and there could be bust and, you know, just like anything else in chainage, you know, slippage of wheels and things of this nature. But you always have that kind of concern. But the nice thing is you always come back to an above ground marker, and you start all over, you know. So you always have references in there to keep you on track.
Gotcha. Question about corrosion again, Joe. I hopefully know what the acronym stands for, but the question is, can HVPL, again, HVPL, cause corrosion on above ground piping?
They're talking about a high voltage power line.
There you go.
Okay, yeah, above ground. Normally, you need a medium around it. You get a capacitive effect once it gets above ground versus an inductive effect. So the only thing you have to worry about is your areas of entrance and exit on each side. That's as far as the above ground. I would say no, as long as you maintain your atmospheric coatings on there, and that's what you should be using versus underground coatings, because they don't hold up as well, you know. So as long as you maintain your coatings on the above ground span, you should be okay.
Okay. Appreciate that, Joe. Again, as more questions come rolling in, please submit them. If we're not able to get to your question today, we will notate it and get back with you personally. So if you have questions, you want to submit them, highly encourage it. Even if we're not able to get to it, we will certainly get back to you today. So, get back to you at a later time. Have a longer question that's broken up in two parts. I'm going to get to the second one first. Even though it's an upstream related question, might be applicable to all aspects of the energy sector. So is there a ruling by PHMSA that you're aware of, Joe, that holds operators accountable if they are sending upset process fluids through the pipeline, which the pipeline was not designed for?
That's a loaded question.
Yeah.
Well, first of all, there's contracts if you got episodic upsets and you're sending fluids to a company and you have a contract with them, you know, that to keep the CO2 levels, the water levels, this and that, all, you know, within the norm. I think it's more of a legal issue, and the problem is if you send corrosive fluids, these fluids that are, you know, they're unanticipated events. This is not a good situation, because you should notify. Number one, a lot of times the producers don't notify the receiver, and they find out by accident by loaded you know, through coupons or through other monitoring devices, or they get flooded somewhere in a pig trap or you know, a dehydration facility. Yeah, you got problems, and somebody has to pay for that to get rid of that stuff. So I think it's more of a legal event, and it could resolve. And I know things happen, but the main thing is make everybody aware of it. So there's no surprises. You don't find this stuff out later, and it runs down the line, and the next thing you know, it gets in your pumps or compressors or whatever you're using, at the time, and then you got flooded facilities. It's not a good situation.
All right, appreciate your kind of opinion and expertise there, Joe. The HydroTest Power tool. Some people are wanting a little more details on that. Just kind of combining several questions into one here. So with that particular program, can it handle a spike test?
That's a great question, and a spike test is usually at least 10 minutes, up to 30 minutes, and then you go back to your normal testing. You could put that information in, but it's really not designed specifically for a spike test. It's really designed for the normal 6 or 8 hour test that you normally run, to keep your pressures, within line, so you don't overpressure your, one side versus, the high side versus the low side, but normally what they do is they'll run everything when everything is normalized. They'll run a spike test for 10 to 30 minutes, depending on the company. All you need is and then bring it back to what it should be, as the regulators require, and keep it within those bounds. And of course, the spike test is for the purpose of finding indications or anomalies that are ready to fail. You're going to try to get them out very quickly. So it's a little bit of a different type of test than when you're dealing for establishing an MALP or a pressure test. Our program is primarily a pressure test type situation, not to blow out anomalies, but it can could be combined with it. That should be just a normal practice if depending on the integrity of the pipe and what kind of defects you're trying to find.
Okay, thank you, Joe. Got a question that I can field here real quick. The question pertaining to what specific applications does the API Toolbox cover? I believe it was kind of glossed over a little bit. So again, just a reminder on the API Inspectors Toolbox. It is a full program for API 653 above ground tank storage inspections for both inspectors, reliability engineers, mechanical engineers alike. There's API 510 for pressure vessel inspections. And then there's API 570, which is for piping inspections.
Right.
Again, what's the beauty of that particular program is it is a lot of different things. It has all of the code bytes and references on a standardized program. It has a complete report building application for standardized reporting, and it has an asset management database where you can track all of your assets, when the next inspection is, et cetera, on a single program for both cloud and desktop capability. We have previous webinars of specifically that program on our YouTube page. We have a success story from clients at large NDT and inspection companies, kind of what they utilize the program for, why they like it. We have a more technical overview to that program with our SME, Jeff Walling. And then we also have a short video that kind of articulates what I explained in 30 seconds and a more 3-minute overview as well. So on our YouTube page, you can see that there. That's for the questions that kind of pertain to what does that program do. So again, it's for inside the fence and outside as well, inspection and reporting programs. So hopefully that was able to answer the question there, to expand on that a little bit.
One thing I'd like to add is that anybody who's worked in a plant environment knows all the API standards or recommended practices that are used. This program brings them all together. So you don't have to have 15 or 20 different API standards open. Everything is all put together that, for your TMLs and everything else, where you don't have to look it up anymore. It's all there. And this is where the speed comes in, where a tech goes and does his work, and then he spends the other half of his time, trying to put this thing together, where you could reduce the time into hours, not days, putting all this information together. And this is where this program, and it's consistent. Yeah, and it'll be consistent among the techs and throughout the company, and it'll meet all the API requirements.
Appreciate that, Joe. We have a number of questions left, but I'm going to answer one more. Looks like there was a question pertaining to on one of the final slides. Technical Toolbox mentioned there's a HDD design program. How does that compare or differ to Borate? Look, Borate is an incredible software application and tool for HDD analyses for pull force and post installation stress, developed by Vermeer. Awesome tool. But what our program is a full design and design validation program and application for horizontal directional drilling. Again, such as the API Toolbox, we also have webinars about that on our YouTube page by David Willoughby. You might have heard his name. He is our internal SME for horizontal directional drilling. But similar to Borate, you can handle your pull force and post installation stresses for both steel and plastic piping. But within our program, you can handle compound angles and bends. You have full control over the design of the bore, meaning you can do it section by section. I know Joe mentioned you can go more than 5 sections. I think Borate can do that as well, but ours has the full control where you can, handle that section by section, create your elevation profile to see how you can maybe reduce the length of that bore and save on cost. It also has the hydraulic fracture analysis in there, which that we reference and partner with the U.S. Army Corps of Engineer Research Institute on the analyses there, and referencing from the Geotechnics book from 1997. The program utilizes the single point delft calculations for that hydraulic fracture analysis there. And then it has a very robust report building program where allow you to do bundled piping pulls and calculations and applications such as that, and also has cables and conduits as well to determine clearances and jam ratios. And you can also leverage your GIS and asset database to do that too. So some differences there, some similarities, but a lot more oomph as regards to that. And of course, having David Willoughby as the SME is always great too, because we reference his book that was released back in 2005, where a lot of the analyses are pulled from that. So with that, everyone, I think we're at the top of the hour. We still have some outstanding questions. Hopefully that helped with the question pertaining to HDD. I do want to thank everyone for attending the webinar today. Hopefully you got a lot of useful tips and kind of Q&A throughout here, kind of seeing what Technical Toolboxes offers in terms of pipeline integrity, but also learning a little bit about pipeline integrity in the industry itself. So we thank you all. If we missed your question, we'll certainly get back with you. Be on the lookout after the holidays for our next webinar, part 2 of the series pertaining to encroachment management. It's going to be all about encroachments, and we'll have Alfredo Sainz there as our SME. So thank you, everyone. If we don't hear from any of you beforehand, hope everyone has a happy holidays, happy New Year's, and excited to start 2022 with you all. Thank you. Have a good one. Bye. Thank you, Mr. Pikas.
Thank you, everybody.